The world of AI moves so fast, it can make your head spin. But what if the biggest breakthroughs aren't the ones you see in the headlines? What if they're actually hidden away in dense research papers, telling us some really surprising and honestly kind of contradictory things about where this is all going? Well, today we're going to unpack those hidden gems.
And let's just kick things off with a pretty provocative question. We all kind of assume that as these AI models get smarter, they're also getting more creative, right? More original. But what if that's not true? What if the very thing we're doing to make them smarter is actually making them all sound the same?
So, this brings us to this fascinating and, yeah, a little bit unsettling idea that researchers are starting to talk about the artificial hive mind. It's a really subtle thing, but it could be a massive challenge, not just for AI, but for our own creativity.
Okay, so picture this. You ask a super advanced AI to give you an inspiring vision for the future. You'd probably get something like this back. I mean, it's positive, sure, it hits all the right keywords, but it's also just incredibly generic, isn't it? It sounds like it was written by a corporate marketing department. Now, here's where it gets really interesting. You ask a totally different AI model from a different company the same exact question, and you get something that is, for all intents and purposes, identical. The words are shuffled around a bit, but the core idea, the vocabulary, the whole vibe, it's the same. And that, in a nutshell, is the problem. So researchers have actually put a name on this. They're calling it the artificial hive mind effect. And it's this trend they're saying where when you give these top-tier AI models an open-ended creative prompt, they all start to land on the same kinds of answers. It's like they're all starting to sound alike. And this whole effect, it's got two layers to it. First, there's what's called intramodal repetition. That's just one AI repeating itself. It's annoying, for sure, but that's not the real issue. The bigger and way more concerning problem is intermodal homogeneity. This is when all the different AIs, from different companies, trained on different stuff, start to sound like they're singing from the same hymn sheet. That's when you've got a real problem on your hands.
So you gotta ask, why does this even matter? I mean, who cares if the AIs are a little boring? Well, the risk isn't just about boring AI. The real danger is that if we're all swimming in this sea of homogenized AI-generated stuff all the time, it could start to subtly box in our own thinking. It could make our own human creativity a lot less diverse in the long run.
Okay, so if we're at risk of AI turning into this big, boring hive mind, how in the world do we break it out of that rut? Well, it turns out some researchers are finding an answer that's completely counterintuitive. The secret might not be to make AI models wider, but to make them way, way deeper. This is one of the biggest questions in the entire field, right? How do you actually get an AI to do something brand new? For a long time, especially for a certain kind of AI called reinforcement learning, the ones that learn by trial and error, kind of like we do, the answer was definitely not just make it bigger. Yeah, for years, the standard rule for these trial and error models was to keep their neural networks super shallow. And I mean, we're talking just 2 to 5 layers deep. The whole idea was that the kind of feedback they get just wasn't powerful enough to train anything more complicated than that. And this is where things just get wild. Some researchers basically decided to just throw that entire rulebook out the window. They went ahead and built a reinforcement learning model with over, get this, 1,000 layers. I mean, that is just a mind-boggling leap. It completely flies in the face of decades of what everyone thought they knew. And the result? Well, the crazy deep network wasn't just a little bit better. It started learning really complex stuff completely from scratch, with no human examples to copy from. This just totally flips the old thinking on its head. It proves this kind of AI isn't just for fine-tuning. It can be a powerful learning engine all by itself. All right, let's switch gears and tackle another really common fear. You hear this one all the time, that generative AI, especially for images, is just a super sophisticated copy and paste machine. But is it really just plagiarizing? Well, new research says the reality is way more interesting than that. So let's just ask the question point blank. Are these incredible AI image generators just grabbing bits and pieces of photos they saw online and stitching them together? Is it just a high-tech collage? It's a totally fair question, and thankfully it's one that researchers have been digging into. And the answer, which is pretty surprising, is no. It turns out there's this really fascinating process going on under the hood. It's got a super technical name, implicit dynamical regularization. But don't worry about that. The idea is actually simple.
Think of it like learning a language. First, you learn the rules, the grammar, the general patterns. You don't just memorize every sentence you've ever heard. Well, it turns out AI training has a built-in phase that forces it to do the same thing, to generalize before it ever starts to just memorize. So check this out. When an AI model is training, it goes through two main phases. Early on, there's this generalization phase. That's where it's learning abstract concepts, like the idea of a cat, not just what one specific photo of a cat looks like. It's only way later, if you just keep training and training, that it hits a memorization phase. And right in between, there's this perfect sweet spot.
And here is the absolute kicker. The bigger and more diverse the training data is, the longer that generalization sweet spot lasts. And this is totally counterintuitive. Feeding an AI more data doesn't just give it more stuff to copy. It actually gives it a much, much bigger window of time to learn the underlying patterns of things before it even thinks about just memorizing the specifics.
And that brings us to our last finding. And honestly, this one might be the most mind-bending of all. It really calls into question one of the most basic ideas we have about how to make AI better, the whole idea of giving it rewards. So we all pretty much assume that when we reward an AI for, say, getting a math problem right, we're actually teaching it how to reason better, like we're installing a new skill in its brain, right? Well, it looks like we might have been completely wrong about that.
The shocking discovery is that this kind of reward-based training doesn't really seem to give the AI any new fundamental abilities at all. What it does instead is make the AI way better and faster at using the skills it already picked up from its first huge dump of training data. So it's not actually learning something new, it's just getting better at finding what it already knows. The research committee put it perfectly. They said this process optimizes within rather than beyond the base distribution of the model. In plain English, that means the AI gets really good at finding the right answer among all the answers it could already think of, but it doesn't learn how to come up with totally new kinds of answers.
And the implication here is, well, it's huge because, yeah, this training makes the AI a fantastic test taker. It gets the right answer, and it gets it fast. But there's a cost. Over time, it can actually make the AI less creative. By always rewarding that one right path, we're basically teaching it to stop exploring all the other interesting and maybe even more creative side roads.
So when you pull all these different threads together, you get this really fascinating and frankly contradictory picture of where AI is at. We're learning that going radically deeper is better, that feeding an AI more data can actually lead to less copying, and that the very way we reward AI might be holding it back. And of course, hanging over all of it is this quiet risk of the artificial hive mind. Which leaves us with what might be the ultimate challenge for the next generation of AI. It's not just about raw power anymore. It's about figuring out how we can build something that isn't just super intelligent, but is also genuinely creative and diverse and an original thinker. Can we actually have both? That might just be the biggest question of all.